For lab exercise 1, we'll apply a strain gauge to an aluminum bar. The strain gauge that was selected is a 13 STC series, so it's compensated for aluminum, and it's a 1/4 inch grid, 350 ohm. The first step is to clean the bar with some sort of cleaner or degreaser. NewSolve works nice. It's an electrical contact cleaner. It does not leave a residue. Next is to use about a 300 to 400 grit sandpaper or emery cloth, and it can also be done as a wet sand operation along with some conditioner A. After the surface is smooth and free of defects, then gauge alignment marks can be applied with an HB pencil. After the marks are applied, then the marks can be removed with a cotton tip applicator and more conditioner A. Then the surface needs to be neutralized using Vichy neutralizer. Then the surface should be wiped clear, wiping from the center of the gauge site and away. That way the gauge site does not get contaminated. Next, take the strain gauge and put it on a glass petri dish that has also been cleaned with conditioner A and neutralizer, and get some cellophane tape. Place the gauge face up on the glass dish and then apply about a 4-inch piece of tape over the top of the gauge. Then carefully lift the gauge up off of the glass affixed to the tape. Then carefully align the gauge with the alignment marks that were burnished onto the test article. You can use a microscope if need be, so you can align the gauge on the gauge marks. After the gauge is aligned, then carefully pull back the tape, leaving 1/2 of the tape affixed to the test article, but revealing the back side or the bottom side of the strain gauge. That's the side that will be bonded to the test article. Next, apply some catalyst C, which is the catalyst used with ME5160. When applying the catalyst C, use it sparingly. Wipe the excess off the brush back into the bottle. Then, using the side of the brush, wipe across the strain gauge, starting on the tape prior to the strain gauge, wiping across the strain gauge, and finishing the stroke after the strain gauge, so not to leave an accumulation on the strain gauge. Then the catalyst C will dry quickly. After the catalyst is dry, 1 drop of ME5160 can be applied at the crease between the tape and the test article. Then carefully, using your thumb, smooth the tape down, squeezing the glue out from underneath the gauge and in between the test article and the gauge. Make sure there's no air bubbles trapped underneath the gauge. Work the glue out and then apply firm pressure with your finger or thumb. Hold it for about 2 minutes and then the adhesive is cured. Then carefully remove the tape using a shallow angle, and the gauge will remain and the tape will be removed. Next, you should verify that the gauge placement is correct, that it is aligned properly. Also, Look for any signs of air bubbles or poor bonding. You can take an X-Acto knife or a fine pick and just test the corners of the grid to make sure that it is bonded to the test article. Next, select some lead wire. This is 30 gauge 3 conductor. I prefer a mechanical insulation removal tool as opposed to a hot wire style. And then you will need a solder station, some flux and solder. A small vise works nice for tinning the leads. Drafting tape will be required. Also, tin the solder tabs on the strain gauge. Apply flux, and then heat the tab and apply some solder. Routinely keep the tip of the solder iron clean. Then tape down the lead wires and then solder them to the solder tabs. Next, using an ohm meter or digital multimeter, verify the electrical circuit. So in this case, we should see approximately a 350 ohm resistance from our red lead to the black or white lead. And last, clean the surface off with some solvent, flux solvent or contact cleaner. And then you can apply some protective coating. There's a variety of protective coatings available. M-Coat A is a good general purpose one.